Now that we have all the identities I'm going to go over, even though there are many, many more we could do, we need to make sure we can use them in specific examples. So I have a couple questions here, and we're going to go through and do our best to solve them. First of all, we have cotangent of 35 degrees. We notice that if I wanted to use my calculator, I don't actually have a cotangent button. So how would I do this? Well, one way would be to turn it into a tangent. So which trigonometric identity takes a cotangent and rewrites it as a tangent? And the answer is one of the cofunction identities that says that tangent of 90 minus theta is cotangent of theta. Okay? This means if I want cotangent of 35 degrees, I'm going to do tangent of 90 degrees minus 35 degrees, or the tangent of 55 degrees. So I could then use my calculator to compute what that was. Okay. Now, in this one, I have this very complicated expression, and my goal would be to simplify it. Okay, and we're actually going to later learn situations where we might want to simplify things like this. So I say, which trigonometric identity does this most look like? The answer should be fairly obvious because there's only one identity that has things like this, and that's one of the sum and difference identities. Now, we have to determine which one, because technically there are four. First of all, we notice that it's cosine, cosine, sine, sine, which makes us think it's one of the cosine sum and difference identities. Then we notice that there's a plus in the middle. So it must be cosine of the thing that was first minus the thing that was second, or cosine of 5x. Okay. Now, this one. I would also like to simplify. I noticed, first of all, that I could factor the 7L. And then I say, this part in the parentheses, which trigonometric identity does it look most like? Cosine squared minus sine squared, that looks like the double angle for cosine. And as long as the angles match, okay, it'll be cosine of twice whatever's in there. So cosine of 6x. Okay? Now we're going to do some actual computations. Okay. We want to be able to compute this, and the point is that we're going to do it without using a calculator. We're going to get an exact answer solely based on what we know of the unit circle. Okay. So first we say, well, I don't happen to know which angle, I don't know the trigonometric functions of the angle 112.5. But I do happen to know the trigonometric functions of the angle 225 degrees because it happens to be on the unit circle. Okay? This leads me to believe that if I use the half-angle identity, I can compute this. This is the only time I'm going to tell you to use the half-angle identity. So, sine of 112.5 degrees will be plus or minus the square root of 1 minus the cosine of twice this, which is 225 degrees all over 2. Now, it's not actually both plus or minus, but we'll compute this out and then figure out which one is the answer. Okay. Cosine of 225 degrees, okay, is negative root 2 over 2. Now, I don't like fractions within fractions, so I'm going to use a little trick to get rid of them. I'm going to multiply top and bottom of the big fraction by the common denominator of the little fractions. And I'm going to end up with 2 plus the square root of 2 all over 4 inside my square root. Now, it's time to determine if it's plus or minus. We are computing the sine of 112.5 degrees. What quadrant is 112.5 degrees in? We pause and think about it, we figure it out, and we realize that it's in the second quadrant. Now, in the second quadrant, is sine positive or negative? And the answer is positive. So we choose the plus. So it is entirely based on what quadrant this angle is in. And if you can't figure that out because you don't know the actual angle, then don't ever use half-angle identity. One more computation, okay? In this case, we don't actually know what the angle is, but we know some information about it, okay? First of all, I know it's between negative pi and 0. Negative pi is here and 0, so it's in quadrants 3 or 4. I know the tangent is positive 5/12. Now between my two options, only one of them will have positive tangents, and that is the third quadrant. Okay? So I put my triangle there. Now tangent is opposite over adjacent. So I can label two sides of my triangle. Now remember that this is the y coordinate and this is the x coordinate. And in the third quadrant, both of those are negative. Now how am I going to get my third side of the triangle? Why, by the Pythagorean theorem. And I don't even need to actually use the theorem if I happen to know that this is a 5, 12, 13 triangle. But by all means, you can do 5 squared plus 12 squared. You'll get 169, so that side must be 13. Now that I have this, I can answer anything I want. So I want the sine of 2 theta. Double angle identity says this is 2 sine theta cosine theta. I had to do that because I only know something about theta, not about 2 theta. So 2, the sine of theta is opposite over hypotenuse, so minus 5 over 13. The cosine of theta is adjacent over hypotenuse, so minus 12 over 13. Okay? And so we see that the sine of 2 theta is 120 over 169, and I was able to compute that without ever figuring out what the angle theta actually was.